The future of tech is already taking shape, not just in companies and research labs, but right here on university campuses. And at Tech Haven, we are launching a new series which is meant to spotlight the bold, innovative projects that students are building across over the country. And we are starting right where it began for me at Ashesi University, so this is a very, very special episode. And in this very first episode, we meet Bridget and Ben, who built an automatic urine analyzer, which is a low-cost diagnostic tool meant to bring basic health screening closer to the people who need it the most. So this is real tech, real problems, and real solutions. I'm so excited for this episode. Let's just get right into it. I'm Michelle Manuel, and welcome to Tech Haven. All right, guys, so let's meet our first set of brilliant students. Now let's go. Hello, Bibi.
Hi.
Hi.
Nice.
All right, so let's take a walk. So this is Bridget, and this is Ben.
Mm-hmm.
So let's just go. So Bridget, let me start from you. What can Ashesi is known for tech and engineering and things like that. I should know. I came here, but why did you specifically come to choose engineering?
Okay, so mine comes from a very interesting story. So before coming to Ashesi, I wanted to do medicine.
Hey, wow.
Yeah.
Okay.
Because I thought that, in my house, doctor, and it gave me that confidence.
Okay.
But during COVID-19, I realized that in my school, the pipes and then the soap, everything was automated. I was so intrigued. I was like, what's the technology behind this design? And I asked one of my friends, and he was like, oh, that's engineering. And I was like, okay, then it's looking like I want to know more about these things. So I decided to go for engineering. What specific engineering? Because I loved electricity in Wesley Girls High School.
Okay.
I decided to go for electrical engineering. I've really not regretted. Like, that's the best decision ever.
I see. I'll have a follow-up question, but before that, let me find out from Ben.
Okay,
Why did you
so
decide to choose engineering?
for me, I think I've always been passionate about tech and computers and all that sort of thing. And so I just grew up in a home where I was lucky to have access to all that kind of stuff. I was always tinkering or doing something with it. And so I just felt engineering would be the next step from there.
Interesting. So let's just go straight to the reason why I'm here actually. So with your project, right? What is the introduction of it? Like, how did it start? What's the problem that you saw that you're trying to solve?
Okay, so I'll take that.
Yeah, you can take that. Yeah.
So first of all, we realized that in Ghana, a lot of people do not really take regular health checkups as serious as it should be. And according to statistics, 90% of people really know about health checkups, but less than 50% of them actually undergo this health checkup. So our idea was to solve this issue. Why not bring the health checkup into people's homes and then make it easier for them to take on this whole journey of looking at their health and all that stuff. So what happened was that for me, it came from a personal story. So I had a family relative who was recently diagnosed of diabetes. She never got to know about it until the symptoms became very severe.
Okay.
But then at least if she had a device like ours, that is UroSense, which is an automated urine analyzer, it would have made life easier as compared to she having that surprise of having all those bad symptoms before.
Okay.
Yeah.
Okay. So essentially, right, what I'm getting from this is that people have issues. People don't have issues with checkup per se, right? But it's like the energy to go and do checkup is stress. So you're bringing the checkup to them, which is cool, I think. So I think also urine is smart because it's everyday something.
Yeah, exactly.
That's awesome. All right. So I've heard you've built something. Of course, I know you've built something that sort of helps that. So why don't you go and check it out and see how it looks like?
Sure.
All right. Okay, baby. What contraption do we have here?
So this is UroSense, our automated urine analyzer. Before I even get into it, urine has a lot of biomarkers. Biomarkers are like protein, pH, blood, etc. So these things help us to have an idea of what is happening in your internal system. Protein, for instance, will give us an idea of your kidney. pH will give us an idea of your water system. Because if you're too basic or acidic, it tells us that you're not drinking enough water. And then we also get to have the glucose, which will tell us more about your sugar levels. So traditionally, what this does is that when you have this strip, you insert it into your urine, and then it will change color. And then you have to read it on the color chart. But the challenge is that with this, it's very difficult to really make meaning of the color difference. When we even tested ourselves, we couldn't even tell what value we are reading because of the color change. But what the system does is that it just gives you the result without any manual intervention from the human. So Ben Charles will take you through how the system works.
First off, so how did you get urine to test or something? Or what did you use to test?
Okay, that's a great question. So we worked with artificial urine that we created ourselves.
Sorry.
Yeah.
You created urine.
Yeah.
You created artificial urine.
Yes.
In this school?
Yes.
Wait. Okay, I don't want to delve too deep into the artificial urine part, but how did you create the urine?
Okay, so urine has a lot of like salts, like sodium chloride and all that. So we did a lot of research, and then we looked at the concentration of all these salts in the like normal human persons, like urine, and then after doing that, we spiked it up with glucose, with protein,
like a typical
human. So like to make it like more natural as compared to artificial.
So you create. Okay, have you tried natural urine yet? Or you don't want to contaminate yourself, so...
Yeah, so the thing is that we didn't try natural urine because natural urine has a lot of like other pathogens and stuff. But what we are trying to do is that right now we want to see if the system is actually able to
detect the levels of what do you call it? The markers, biomarkers.
The biomarkers.
Yes, awesome.
Biomarkers.
Okay, so just to be clear, I just want to make sure I get it.
Yeah.
Biomarkers are in urine and stuff. I'm sure sweat too has biomarkers.
Yes.
Good. This typically you put it in and then you see a color and it will tell you a pH level, which can tell you something about it, right? But that will just tell you one particular biomarker. So just one thing you can test in particular, or one or a couple of things you can test, but it doesn't tell you the whole spectrum. This gives you access to a lot more biomarkers that you can test. Awesome. Let's get into it.
Okay, so Ben Charles will take you through. So I'm going to give him this strip.
Okay.
And then we have a sample here. So we are going to use that.
This is the what?
It's a sample of
artificial urine.
Yes.
So this one, if it's a human, I can see the human have drank a lot of water because it's very clear. Probably the person is even sick, but this is clear urine.
So typically what you would do is you would dip the strip in, take it out, and you wait a few minutes for the color to change. As you can see, there's already some kind of coloration on it, right? So whilst we are waiting for that, we can take a look at the mobile application. So what the mobile application does is that once you put the strip into the machine and it finish reading, it would send the information to the mobile app. Then the mobile app will give you some insights and to try and make predictions of your health status and various other things.
Okay, so just to confirm, it's the app is connect. You created the app yourself, custom app. It connects to this thing. Sends it over what does it send it? How does it send it? Bluetooth, Wi-Fi?
It works over local Wi-Fi connections.
Okay.
So it creates a server. And then you just connect and then
so it's like a local internet. Sort of, yes.
So now that it started changing color, we would take out the mobile app. And as you can see, there's already some past results, and it's continuously refresh, waiting for information.
But so this is the past results inside already, and how come to put this one inside for it to read it? Okay, all right.
So put the strip in.
So wait, the strip is it capturing a picture of it?
Yes. So that's
you're using visual. Okay. So how long does it take? Does it take the whole system to do it and then send you the information?
Okay, so it takes less than 30 seconds and you would get your results.
Okay, so 30 seconds and you can. So with this results, right, I'm seeing things. I don't know what they mean.
Yeah.
How is the end user going to interpret that and for it to be useful to the person?
Yeah, so that's a great question, and that's what we thought about. So if you would click on any of them, you would see that it tells you a little bit about it.
So the person is in trouble?
Yeah, so based on their last reading, they are in trouble because the normal range of protein is 0 to 14 milligram per deciliter. And so with what we have over here, it's telling you that it's above 30 milligram per deciliter. So you should try and see, you should consult a health professional. So it tells you that it's really urgent. You have to go to see a health professional.
So your kidney is not breaking down the protein, so it's just coming through the urine.
Exactly.
Okay, awesome. So you've probably created like 4 or 5 artificial urines that have different concentration of things to test it, and all of them have worked so far.
Yeah.
Awesome. So the machine learning, and then what element of it was the machine learning?
Yeah. Okay. So the machine learning comes in with the image capture and processing.
Okay.
So as you saw from the camera and the strip, we are trying to give the machine better eyes than we would normally have, So it would capture the image, compare it to the machine learning training it has on the images, their corresponding values and all that. And so I don't know if I should go too technical by mentioning the models, but then, yes, that's what it does basically.
Maybe you can just mention 1 or 2 so that I can just use to flex more.
Okay, so it uses models like K nearest neighbors. So what that
It's a model called K nearest neighbors.
K nearest neighbors.
I am outing myself.
And so K nearest neighbors, there's linear regression.
Yes, I have heard of it.
Yeah, so various other models like that all come together to help us visualize what's happening and give the right prediction of what exactly is the value the strip is trying to communicate. Then also for the predictive models, we're also using models like ARIMA, which is autoregressive integrated moving average.
Okay, now we are going into the...
I know it's getting a bit complex, but what it does basically is using your past data to try and predict future data. So that's how we are trying to predict for users.
Okay, in 1 minute, what was the biggest challenge that you guys faced while building this?
Okay, so first of all, I spoke about the height. That was one of our biggest challenges because of the camera. And secondly, the lighting. So initially, as I said, we used like normal LED bulbs and all that, but it was affecting our results because we had calibrated with a specific amount of light, and then when we put a strip inside, it was giving us very wrong values. So we had to recalibrate and change the whole lighting system. That's why we have the LED strip that you can see. And also with the artificial urine, when we were testing for the acidic and basic urine, it was fading our strip badly. It was because, the human acid is not as strong as the artificial one. So it was very overwhelming. Like, it was just fading and we were like, oh my God, what's happening? But at the end, we're still able to, we had to recalibrate our system to fit that environment to ensure that, okay, can it actually predict?
And you went to reduce the acidic component of your artificial
Exactly, because it was making things very,
Is there on your side for the...
Yeah, I would say it's not really a challenge, more of a limitation.
Okay.
So for the strip capture, we really wanted to have, let's say, computer vision models to be able to view the strip and then analyze it, detect the various patches for each of the biomarkers. But then there's no database or any sort of machine learning model that exists currently that has been trained on identifying the various sections. So we had to come up with that ourselves. And so that's where she mentioned the cropping algorithm and all that we had to work on. So
does this exist already? I'm asking because I know typical Ashesi will tell you what new have you added to the product that exists already. So I'm sure some sample exists somewhere. How does this differ?
Okay, so the ones that exist are actually not like this.
Okay.
So those ones, they also automate the reading, but they don't have predictivity. So for us, we decided to give you what is going to happen to you in the future, looking at your past data. And also, this is very affordable. This is approximately $72. The one on the market is about
$600.
Okay, $600. Sorry.
Yeah.
So that's like a difference. So like we've reduced the cost. And also, if you're looking at, you don't need the technical expertise. As you saw when Ben was demoing, you just have to insert and then wait for about 60 seconds and just insert. That is all. But the other ones, you need to know it. It's very technical. You need to know some technical knowledge and all that before you can use them. So we also remove that aspect from there. Yeah.
That's cool. All right, guys. I think you guys have done an amazing job. I'm impressed. And I came here, so... so yeah, this is pretty good. I'm excited. I understand why the supervisor was excited to show this. I think this is this could help a lot of people.
Yeah.
Especially people, even for those who probably don't have a lot of money. Yes, $72 is expensive, but you could have one that is shared between a number of people, and then although the urine aspects, but you can figure that one out.
Yeah.
But I think that is pretty cool. I think that, yeah, I can see a potential. You want to continue this after school, or you are now thinking about the whole thing. You don't worry. If you don't want to
Okay. That's a question, or that's an answer for the future. So yeah.
Okay, yeah, that's cool. All right, guys. Thank you so much for taking us to your work.
I'm glad we could share.
Yeah, that's good. That's good.
And we are hoping that UroSense would actually help people to have an informed health status as planned. Because as you could see, it was very easy to use. And at the end, your health is your wealth. So, yeah.
You have to add a punchline.
Oh, yeah, right.
All right, guys. Thank you so much for staying with us. This is UroSense.
Yeah.
Same. I was trying to give a punchline. Mine is not coming back. All right, guys. I'll see you next time.
Bye.